Hello dear students, I welcome you all in lecture number 2 of this amazing chapter Acid, Base and Salt. So let's begin this lecture without wasting much of our time. So let's see, here we are. Now guys, here we will discuss what is alkali. So what is alkali? Basically guys, alkali is nothing but a base which can be dissolved in water. We all know that all bases do not dissolve in water, but an alkali is a base that dissolves in water. Okay, so now let me tell you some of the properties of this alkali. So after understanding that alkali is a base, so they will show some of the properties of base. So the first property is bitterness. Alkalis are bitter in taste, and I do not need to explain why are these bitter, because these are bases and bases are also bitter in nature. The second property is the corrosive nature. Bases are corrosive. Bases are what? They are corrosive in nature. So alkalis are also corrosive in nature. Okay, I hope guys you are able to understand whatever I am speaking here. Now these are soapy to touch. These are soapy to touch. If you touch it, then it will feel like a soap. So these are some properties of the alkalis, that they are very corrosive, they are soapy to touch, they are bitter. Now guys, after understanding this, let's move on to the examples of the alkalis. So let me write here some of the examples so that you might be able to understand it. So guys, the first example is NaOH, and we all know what is NaOH. This is sodium hydroxide. Sodium hydroxide. Other example of this, KOH, which is potassium hydroxide, and calcium hydroxide, CaOH whole twice. This is also another example of alkalis. Okay, so I hope guys, after understanding these alkalis, we might be ready to see the other concepts of this chapter. So let's move ahead to the next topic, and that is the chemical properties of acid and bases. So we will talk about the chemical properties of acid and bases. So let's talk about the first, chemical nature. Basically when I say chemical properties of a acid or a base, then I mean to say that I am talking about the reaction which they show. Okay, which type of reaction do they show? How do they react with different compounds? Okay guys, so let's see what are the reactions of acid and bases. So the first reaction is, whenever acid reacts with base, it forms salt and water. Okay, whenever acid reacts with base, it forms salt and water. Now this is a very basic reaction which we have been studying since very first time. Okay, and let's see the example of this reaction as well. HCl, which is an acid, when this react with a base, NaOH, this is a base. When these two reacts, they form NaCl plus H2O. So this is acid, this is base, and salt is formed in this reaction. and this is also known as common salt and is used in our houses on the daily basis. Now guys, after understanding this, let's move ahead on the next slide and let's talk about the other related things. Okay, so here we will see the chemical properties of acids. So whenever acid reacts with metal, they form salt, and hydrogen gas is also evolved in this reaction. Okay, whenever acid reacts with a metal, it forms salt and hydrogen gas is also evolved. And same thing happens with bases as well. Whenever a base reacts with metal, it forms salt and hydrogen gas is also evolved in this process. Okay, I hope guys this thing is clear to you. Now, one more thing I want you to know, that to detect whether hydrogen gas is evolved or not, we pass this hydrogen gas into the soap solution, of soap, and whenever you bring it close to a burning candle, then this candle will burn with a popping sound. Okay, so we will talk about these things later, but before, we will see some of the example of these reaction. Okay, so let's see what are the examples or what are the reaction what acid and bases show. So when Zn reacts with HCl, which is an acid, then it will form ZnCl2. This is zinc chloride, and hydrogen gas is also evolved in this process. Okay, and if I talk about reaction of base with metal, then let me tell you that whenever NaOH, which is sodium hydroxide, reacts with zinc, then it will form Na2ZnO2. This is basically sodium zincate, and hydrogen gas is also evolved in this reaction. Okay, so I hope guys you might have been able to understand the reactions of the acid and bases with metal. So what will form here? Salt and hydrogen gas will be formed as a product of this reaction. Okay, and you can try the different reactions as well by changing the metals and the acids. Now guys, after understanding this, let's move ahead and let's talk about the other reactions of acid and bases. So here we are. Here we have to study reaction of acid with metal oxide. Just on the previous slide, we saw the reaction of acid and bases with metal, but here we will see the reaction of acid and bases with metal oxide and non-metal oxide. So guys, I want you to know one thing. Because of that, you will be able to understand easily what is the product of this reaction. Although you already know this because it is written here, but I think most of the students do not know the logic behind it. So let me tell you how this reaction will work. So basically guys, metal and their compound, or you can say that most of the metal and their compound are basic in nature. They are what? They are basic in nature. So when an acid reacts with metal oxide, and we know that metal oxide is a compound of metal. So we know that metal and their compound are basic in nature. That's why this metal oxide will act as a base because it is basic in nature. And we all know that whenever an acid and a base react, then salt and water will produce. So you can see, let me take you to that slide here, that acid is reacting with base and salt and water is produced. So the same thing will also happen here. When this acid react with base, then salt and water will be produced. Now guys, to tell you the example of this, let me write an example here. I am writing here HCl, which is hydrogen chloride, and it is an acid. I have been telling you this again and again. I hope it might have been by hearted by you. Now for metal oxide, let me take calcium oxide. Calcium is a metal and it is the oxide of calcium. So this is a metallic oxide. Now we all know that metal oxide are basic in nature. So it is like a base, and whenever there is a reaction between an acid and a base, then salt and water is produced. So CaCl2, which is calcium chloride, it is a salt which is produced by the reaction of this acid and base. And guys, water is also produced in this reaction because it is a neutralization reaction. We all know that the reaction between acid and bases are known as neutralization reaction. So it is also a type of neutralization reaction. I hope guys this thing is clear to you. Now let's talk about the reaction between non-metal and base. So guys, to understand this reaction, you also have to know one more thing, and that thing is that non-metal and their oxides, or you can say non-metal, or their most of the compounds are acidic in nature. They are acidic in nature. So metal and metal compound are basic in nature. On the other hand, non-metal and their compound are acidic in nature. So when you are reacting with this acid with base, then salt and water is produced, because we know that whenever there is a reaction between an acid and a base, then salt and water is produced. So this is also a type of neutralization reaction. Let me write it here for you: neutralization reaction. So guys, if I give you an example of this reaction, then NaOH, which is sodium hydroxide, and when this sodium hydroxide react with SO2, this is a non-metal oxide, and when these two react each other, then it will form Na2SO4 plus water. Okay, I hope guys you understand this. Now let's move ahead to the next slide. So this is our another slide, and here we will talk about the other reaction which is shown by acid. So whenever a acid reacts with metal carbonate, it will form salt, water and carbon dioxide. So guys, as I told you on the previous slide, that metal and the most of the metal compound are basic in nature. So this is what? This is metal carbonate, and this metal carbonate is basic in nature. So it will form salt and water, because whenever acid react with base, it forms salt and water. But in this case, what will happen? Because this is metal carbonate, then one thing is extra. One thing is formed extra, and that is carbon dioxide. On the other hand, we have seen on the previous slide that whenever acid reacts with metal oxide, then salt and water is formed. But you have to understand the difference between these two reactions. When acid reacts with metal oxide, it gives salt and water, but when it reacts with metal carbonate, then one thing is formed in extra, and that is carbon dioxide. So to make you understand this simple thing, let me write down an equation for you, or a chemical reaction for you, so that it will be easier to understand. So again we are taking HCl, which is very famous acid, and we have been using this acid to understand the reactions. So it is a very helpful acid for us. So when this HCl reacts with an A2CO3, this is what? This is sodium carbonate. Sodium carbonate. Okay, this CO3 is what? This is carbonate, and this is sodium. So this will become sodium carbonate. Now guys, how I am writing these formulas, we have learned this thing in class 9. So this is very important. Now guys, when this acid reacts with sodium carbonate, it will form again NaCl, and this is common salt. Water will also be formed, and carbon dioxide is also formed in this reaction. Okay, so this is what? This is carbon dioxide, and this is the difference between this reaction and the reaction which we have studied in the previous slide. I hope guys you might have been able to understand what I am trying to make you understand. Okay students, now we will see other reactions as well. So let me write another reaction, and here HCl is reacting with an AHCO3. This is NaHCO3. This is sodium hydrogen carbonate. This is what? Sodium hydrogen carbonate. So when this sodium hydrogen carbonate reacts with HCl, then because this is a metallic compound and this is the metal carbonate, then it will form a salt, and in this case the salt is an ACl, plus water will also be formed, and carbon dioxide will also be formed. So this is an example of this reaction. So we have seen two examples yet. First example is HCl reacting with sodium carbonate, and in the second example we have seen HCl reacting with sodium bicarbonate. So after understanding this reaction, let's move on to some other points as well. So guys, as you can see that carbon dioxide is evolved in this equation. So if we want to check whether carbon dioxide is evolved or not, what can we do? So to check the presence of this, we do one thing, and we pass this carbon dioxide into the lime water. Okay, and what is this lime water? So let me write down here. Let me change the pen first. So this is basically lime water, and lime water is nothing but the solution of slaked lime. So this is CaOH whole twice. This is calcium hydroxide, and lime water is the solution of sodium, or you can say calcium hydroxide and water. So this is known as lime water. So let me write down the equation. When you pass the CO2 in this water, then what will happen, guys? Let me write it here. So CaOH whole twice, and when I pass carbon dioxide into this, then it will form CaCO3, and this is calcium carbonate. And basically, guys, this is a white precipitate. This is white precipitate. So guys, the color of this calcium hydroxide or the lime water is transparent. Okay, because this is water soluble, and the color of this water soluble substance is what? It is transparent. Okay, but guys, when we pass carbon dioxide in this solution, then it will form CaCO3, which is not water soluble. Okay, not water soluble. So guys, what will happen? If it is not water soluble, then it will not be transparent. So it will, the, or you can say, the color of the solution will become white, because this is white precipitate. This is a white precipitate. That's why the color of the solution will also become white. So the color of lime water is transparent, or you can say it is colorless, but when it reacts with carbon dioxide, which we have passed from this reaction, which is produced in this reaction, and we pass this carbon dioxide into this, then it formed calcium carbonate, which is a white precipitate. Okay, but guys, one thing you have to remember, that if you pass this carbon dioxide into excess, okay, or for a long time, then what will happen? This CaCO3 will again react with this carbon dioxide and with water, which is already present in the solution. So if you pass this CO2 into excess, then these three will again react, and they will form calcium hydrogen carbonate. Okay, this is what? This is calcium hydrogen carbonate. Okay, so guys, this is again water soluble. This calcium hydrogen carbonate is water soluble. So because it is water soluble, then the color of the solution will again turn to the transparent. Okay, so if you add water soluble things into water, then the color will be transparent. But if you add, or if you mix a substance which is not water soluble, then the color of the water will become change. So I hope guys, this thing you might have been able to understand. Now after understanding this, let's move ahead on the next slide, and let's talk about the other important thing related to this. Okay students, so here we will study about concentrated acid and base. Okay, so basically the concentrated acid and base are the acid and bases which are in their pure form, or you can say pure acid and bases are known as concentrated acid and bases. On the other hand, what is dilute acid and base? So dilute acid and bases are the acid and bases when you add water into that acid or base. So if you add water in it, then it will become dilute acid and base. But if it remains in its pure form, then it will be known as concentrated acid and base. So I hope guys this thing is clear to you. Now we will talk about how do we dilute an acid. Okay, how do we dilute an acid? So as I told you that dilute acid and bases are the acid and bases where you add water in it. Okay, but guys, let me tell you how do we dilute an acid. Let's suppose if this is a container and it has acid inside it. There is some acid inside it, and let's suppose you have another container which has water. So to dilute it, if you are adding water into an acid, then this way to dilute acid is wrong way. This is wrong. It can damage you. Okay, so what is the right way to do or to get this thing done? So guys, we have to add acid into water, or what you can do, let's suppose if there is water already inside this container and you have acid into this container, and what you are doing, you are adding this acid. This is what, this is acid and this is water. So you are adding this acid into the water, and after adding some drops of acid, you have to stir this water with the help of something. You have to stir it constantly. Okay, or we can say that you have to add acid into this water slowly, because acids are sometimes very dangerous as well. So to make it a little bit more, you can say, convenient for us, so you have to add acid into the water and not water into the acid. So this is the right way to dilute an acid. I hope guys, yet we whatever we have seen is clear to you. Now after understanding this, let's move ahead on the next slide and let's talk about the other related things. So at this slide we will see some of the examples so that a concept will get clear more. So let's see what are the examples we are going to see. So the first example is in front of you, that why should curd and sour substances not be kept in brass and copper vessels? Okay, so guys, the answer of this question is that the curd and the sour substances have acid inside it. Okay, when I told you about curd, then curd has lactic acid. Okay, and the sour substances have also acids, because acids are sour in taste. So if you keep it into the brass and copper vessels, then these are the metals. And we all know that whenever metal reacts with acid, then it forms salt and hydrogen gas. Okay, so guys, what will happen if you keep curd and sour substances into brass and copper? Then it will form a salt and it will corrode your copper container. Okay, so that is the reason that we do not keep curd and sour substances into brass and copper vessels. So guys, you also can think that what is this brass? So this brass is nothing. It is also a metal, but it is a metal alloy. Okay, and it is, you can say, it is formed by mixing two metals, zinc and copper. So when we mix two metals, then it is known as alloy. So this is an alloy of zinc and copper. So guys, this is also a type of metal, and we all know that metals are basic in nature. So because of this reaction, we do not keep the curd and sour substances in brass and copper vessel. Now guys, let's talk about the second question. So which gas is usually liberated when an acid reacts with metal? So this is another easy question. Here the question is asking to us that which gas is usually liberated when an acid reacts with metal, and how can we test the presence of this gas. So in the above reaction as well, you can see that when acid reacts with metal, here you can see acid is reacting with metal, so salt and hydrogen gas is formed. So which gas is liberated? Hydrogen gas is liberated. Hydrogen gas is liberated. Now how can we detect whether this gas is evolved or not? So I told you when I was discussing about this reaction that to detect whether hydrogen gas is formed or not, what do? We pass this hydrogen gas into the soap solution, and the bubble which is formed, what do? We bring it closer to a burning candle, and now the burning candle will burn with a popping sound. So if popping sound is coming, then we can say that hydrogen gas is evolved. Okay, if it doesn't happen, then we will say that hydrogen gas is not, or you can say it is not evolved. I hope guys this thing is understood by you. Now let's talk about this third example. Okay, so this third example says that metal compounds A react with dilute hydrochloric acid to produce effervescence. The gas evolved extinguishes a burning candle. Write a balanced chemical equation for the reaction if one of the compounds formed is calcium chloride. So basically guys, in this question, two hints are given. Let me take you to the next slide. So two hints are already given in this question, that one of the product of this reaction is calcium chloride. Okay, so calcium chloride, what is the formula for calcium chloride? CaCl2. I told you in the beginning that when I was teaching you the previous chapter, chemical reaction and equation, that knowing the chemical formula is very important. So this is calcium chloride. Now HCl will be on the reactant side. Why? Because it is given that metal compound A reacts with dilute hydrochloric acid. So that's why it is in reactant side. Now guys, it is also saying that the gas which is evolved in this reaction extinguishes a burning candle. So for your information, carbon dioxide is a gas which is used to extinguish a candle. It is also used in the fire extinguishers because it extinguishes the fire. So that's why this carbon dioxide will also be a product of this reaction. Now guys, it is saying that metal compound A reacts with HCl. So what should be this metal compound? So guys, I have told you about this reaction of the acids with metal carbonate. So you can see whenever acid reacts with metal carbonate, then salt and carbon dioxide and water is formed. So here also a salt, which is calcium chloride, is formed and carbon dioxide is formed. So that's why guys, it might be a metal carbonate. This reactant A might be a metal carbonate. So which metal carbonate is it? So you can see in salt, this is the salt of calcium chloride. Okay, this is the salt of calcium. So that's why the metal carbonate will also be of calcium. So this should be CaCO3, which is calcium carbonate. Okay, now guys, in this reaction, water is also formed. Water is also formed. So this is the complete reaction, and you can simply see that whenever acid reacts with metal carbonate, then it forms salt and carbon dioxide and water. Okay, now guys, we will try to balance this equation, because balancing is also very important. So let's see how to balance it. So guys, you can see that the number of hydrogen on the product side are 2. Okay, so to balance the number of hydrogen, I will simply multiply here with 2. And if I multiply here with 2, then the number of hydrogen will also become 2 on the reactant side. That's why hydrogen is balanced. Now, you can see that chlorine has also become 2, and on the product side, chlorine here also it is 2. So that's why chlorine is balanced. Now, let's talk about this calcium. So calcium is 1 on the reactant side, and on the product side it is again 1. So it is also balanced. Now if I talk about carbon atom, then here also carbon is 1, and here also on the product side carbon is 1. That's why carbon is again balanced. Now guys, let's talk about the oxygen. So here oxygen is 3, and here also you can see that 2 plus 1 becomes 3. So here also oxygen is 3. So now this equation is balanced. So I hope guys, the 3 examples which we have seen above is got understood by you. So thank you so much guys, and we will meet in the another lecture. Thank you so much, and bye bye.